Welcome to CS420 Lecture 8, and today we're going to be talking a lot about recursion. So we're going to go through a couple more complex examples than we did in Lecture 7. So make sure that you have the steps to writing a recursive function written down somewhere or take a screenshot so that you can refer to these as we do these problems. And the first problem, we are going to be operating on a S-list. Now an S-list is just like a list of symbols, except here where we normally have a symbol, we have a symbol expression. And let me just finish that out. So a symbol expression is either a symbol or it's another S-list. So right here, we're basically going to be able to put a symbol, or we can embed another S-list inside of it. So what that means is that we can add lists inside of our lists. So let's see a few examples of those. So right here we have just a list of symbols, a single list of symbols. Now if we want to, with an S list, we can have symbols in here. But each symbol, if we want to make it another S list, we can. So we could put parentheses around it and put in some more symbols. Now each symbol inside of this list as well can also get turned into another list of symbols, and so on. We can turn one symbol inside of here. Now it's not just one, we can do more than one too. So we can replace that guy with more symbols. And just as long as we make sure our parentheses all close, that then we have lists inside of lists that could be inside of other lists and so on, as deep as we want. So this allows for a little bit more flexibility with our data. So we're going to write functions that deal with an S list. Now in this next example, we're going to use mutual recursion. Mutual recursion means we're going to have two separate functions that will call each other in a recursive manner. S-list will recurse on S-list, but it will also call a function that handles symbol expressions. Symbol expression will handle symbols, but it will also call the function that manages S-lists. So let's get started. What we're going to do is write a function that substitutes one symbol for another symbol. Now this is what we want to have happen. We're going to call the function substitute, and we're going to pass it three parameters: one symbol, another symbol, and an S list. So the first symbol is the new symbol that we want to appear, and the second symbol is the symbol that we want to get replaced by the first symbol. So you notice this B right here gets replaced with an A in our answer. And then this B gets replaced with an A as well. So we replace all the B's, and there's one more B right here that will get replaced with an A. So we replace all of the B's with A's. So that's our goal, is to write a function that will do that. So we'll get started by using a define. We're going to define substitute, and our function is going to take in three parameters: the new symbol, the old symbol, and an S list. Now if you notice, our first step is to create a function for each non-terminal. In the previous lecture, that was kind of obvious. Of course we want to create a function, but we only had one non-terminal. In this case, we have two non-terminals, so we'd create two functions. So you can follow steps 2 through 5 on the first function, and then do steps 2 through 5 for the second function, or you could kind of do it together. I'm going to do steps 2 through 5 for the function that handles S lists. Then I'm going to create a function that will handle symbol expressions and do steps 2 through 5 for that. So let's go back. We created our function. That's step 1. Step 2 is to separate our productions. So we have either an empty list or a full list. So we need to figure out which kind of S list do I have. And we'll use an if expression for that. If null S list. So if the S list they passed in is null, that means it's the empty list. So we'll just put empty right here. And if it's not null, then it's a full list. So step 3 now is to break apart compound data. Well, we can't break apart an empty list anymore. So next we got to break apart this full list. So the car will get us the symbol expression, and the cutter will get us a symbol list, or an S list. So let's go ahead and do car of our S list and cutter of the S list. So again, S list is what we're operating on. The new and the old are just the old is what we want to get replaced, and we want to replace it with the new. So and so that's why we're taking the car of the S list, because that's our symbol list that we're trying to recurse on. Okay, step 3 is done. We've broken apart the compound data. So now let's move on to step 4 and recurse where we can. In this case right here, we have a symbol expression, the car, and in this case right here, we have an S list, so the cutter. So let's go ahead and recurse on that. So since this cutter is another S list, we can just substitute. And now we have to make sure we have all of our parameters. We have new, old, and S list. So let's substitute new, old, and the cutter of the S list. Now this is always really important. You don't want to call substitute with the exact same parameters that you were called with. You should be modifying at least one parameter, making it smaller, getting toward a goal. Now in this case right here, there is, this is a symbol expression. So we're going to call the function that handles symbol expressions. Now that function hasn't been written yet, but we'll just pretend like it has and it works. And I'll call it substitute-se. Now that's the trick to writing recursive programs, is pretending like these functions work exactly like they're supposed to before we've ever even written them. So I'm going to pretend that substitutes all of the symbols, and I'm going to pretend like this substitutes all of the symbols. So this will substitute all the symbols in my symbol expression. This will substitute all of the symbols in my S list, and now I just kind of need to combine the results together. Now this thing is also going to need the new and old parameters as well, so let's make sure we pass those in. Okay, now we're on to step 5. And that's the hardest step. That's where it's going to require you to think the most. Once again, we could write a program that would take this in as input, and it can completely create this, right? This, all that we've written so far. So all you have to do is follow the pattern and write it out. But now step 5, it becomes the hard step. We want to combine the results and return the correct answer. So if we have a list with no symbols inside of it, and we're asked to replace symbols inside of it, well, we'd probably just give them back a list with no symbols inside of it. Now, one thing that does help you when you're combining results is to make sure you know what your return type is. This is returning a S list, or a list of things. So we know that we always should be returning a list. If our answer is a number or a Boolean or something else, then we should be returning what our answer is. So if it's a number, we should probably return a number here. If our answer is a Boolean, then we should probably return a Boolean here. But we are returning a list, so that's why I am returning a list up here. Now, the other thing on combining the results is to go back to our BNF and realize what each type is. Now the S list, it's just going to replace symbols in an S list. It's not going to change its type. So this is still, when it returns, we're still going to have an S list. And up here, we're still going to have a symbol expression. This isn't going to change what the car is. It's just going to replace symbols in it. So we have a list and an element, and we're calling our element symbol expressions. So when we've taken the list apart, we end up with an element and a list. And to put it back together, we just need to cons the element onto the front of the list. So just cons those two together, and our substitute function is done. We've done all 5 steps. Now you might be thinking, wait a minute, we never replaced any symbol. We didn't even look at our symbols. Well, of course, if we look in this BNF, there is no symbol inside of this BNF. We never had a symbol to look at or to replace in this function. The function that has to replace our symbols is going to be the function that operates on symbol expressions, because they have symbols that we can look at. So let's go ahead, let's move on into creating this function that operates on symbol expressions. And once again, I'm going to call this define substitute symbol expression, or -se, just like I decided it would be up here. And it's going to be a function that takes in a new symbol, an old symbol, and a symbol expression. All right, now that we have this function, let's follow our steps. So step 1 was to create the function. Step 2 is to figure out what kind our symbol expression is. Is it a symbol or is it an S list? So we're going to use an if to figure out, we're asking a question, what is this symbol expression? Is it a symbol or an S list? Well, luckily there is a function called symbol question mark. Again, whenever we have the question mark, that means we have a predicate, and a predicate always returns true and false. So is our symbol is our symbol expression a symbol? If so, then we can say, yes, this is a symbol. If not, then we can say this is an S list. All right, so if we have a symbol, then we want to replace it. But let's go ahead and move on to, we've broken apart our, or we figured out what production we have. And the next step is step 3, break apart compound data. And yes, we can break apart an S list. But you know what? We already have a function that handles S list. So there's no complex data to be broken apart, because we've already have a function that works on S lists. So we're going to move on to step 4 and make the recursive calls. This will just be substitute new old SE. We know the symbol expression is an S list, so we're just going to pass it off to this function to handle it. This is the function. Substitute is the function that handles S lists. Substitute SE only handles symbol expressions, so we can just pass that to that function. And now the name mutually recursive, because this is calling this function and this is calling this function. So you kind of have a cycle of these calling each other. And that's why this is called mutual recursion. Now, the final step. Step 5, we got to combine our results, return the correct answer. The step that we have to think about, this is a symbol. We want to know if this symbol is equal to the symbol that we want to replace. Is the old symbol that we want to replace equal to this symbol that we're looking at? If so, we want to replace it with the new symbol. If not, we want to just keep it the same. So that'll work right there. Now we can close off all of these parentheses, and we're actually done. So just to review this, we're going to say, is this symbol expression a symbol? If so, is the symbol equal to the old symbol? Yes, then replace it with the new symbol. No, then leave it the same. Okay? If this is not a symbol, then it must be an S list, because our BNF says that symbol expressions are either symbols or S lists. So if it's not a symbol, it must be an S list, and this first function handles slist, so we'll just give it to him to take care of. So let's see if this works. I'm going to delete the answer down here. I'm going to copy this because I have to run my code up here to get it to work, and we'll paste that back in, and we can see that all of the B's have been replaced with A's. So now we're going to move on to another example that's going to operate on a BNF for a list of symbols. So the S list was a little more complicated BNF. This is a lot simpler BNF. But what we want to do is we want to take in this list of symbols, and we want to annotate each symbol with the position in its list. So A is in the first position, B is in the second, C is in the third, and so on. So how are we going to do that? Well, let's follow our steps for recursive programming. So we already have our function written. That's step 1. Step 2, figure out what kind of list of symbols we have. Do we have an empty list or a full list? So we're just going to go if null, our list of symbols, and we have an empty list, else we have a full list. Now, step 3, break apart compound data. So we have this here that has 2 parts to it. So we could take the car of the list of symbols and get our symbol, and we can take the cutter of our list of symbols and get the rest of the list of symbols. Now, step 4, recurse. So this is another list of symbols, so we're just going to annotate, we're going to recurse on that function, the original function. And now step 5, that's the hard part, combining the results together and returning the correct answer. Now, if somebody handed me an empty list, I would expect the answer to be an empty list. So that part is pretty easy. And again, remember the return type. We're returning a list, so we better be returning a list up here. So next, what we want to do is somehow turn this single symbol, that's just A or B or C, we want to turn it into this right here. Now I don't know how to get the numbers incrementing right now, so I'll just be satisfied into just say A1, B1, C1. So how we can do that, if we want an extra set of parentheses to show up. Now notice there are no parentheses around this A, but in the answer we want an extra set to show up. So how I can do that is just create a list out of this symbol. So that puts A inside of a new list. And I'll put the number, the position, and I'm just going to hard code 1 every time. I'm going to put that right there. So that creates this part. And now we just have one element. We want to combine it onto a list of elements. So once again, we're going to use cons and combine those together. We can close off all of our parentheses and run this. And let's try to annotate A, B, C. And we get A1, B1, C1. Now the only problem is we want this to be different. We want it to increment as we go up. So how are we going to do that? Well, we're going to need another parameter to keep track of how deep we are into this list. And I'm going to call that POS for position. Okay. Now the original annotate function that we're trying to write, we want to keep it to be called annotate. So I'm just going to call this annotate aux. Now once I change that, I got to remember that was calling that. So I got to remember to change it down here as well. And it now takes 2 parameters. The first parameter is a list of symbols, and the second parameter is a position. But as we recurse down, let's just add 1 to our position. So the next time we call this function, it'll be 1 higher. And then instead of putting 1 there every time, we can put our position. So this adds 1 to our position. We take 1 element off of the list. So if we had a list with A, B, C, now we just have a list with B, C in it. We're passing in 1, but now we're going to pass in 2. So both of these parameters are going to change. Let's go ahead and see what this does. And we're going to have to call this annotate aux, and I'm going to pass in 1 to get started for our starting position, and we'll press enter, and now we got the right answer. The only problem is my customer or the homework assignment that you're trying to do really wants this function to be called anno, not anno aux. So what we do is we just wrap this function. Also, they're not going to pass in 1 to get you started. So we can just wrap this function in a new function, define anno to be a function that only takes in the 1 parameter, because remember anno only had the 1 parameter, and it will call anno aux with that 1 parameter, and we can get it started with the 1 that they need to pass in for it to begin. So when we do that, now we can just call anno and we see that it increments. Now if you're reading through the lecture notes, you'll notice that there is a fringe function, and it doesn't really have an example of what it does, so I want to show you what fringe does. Is it takes out the list inside of the list. So if you notice, we have ABC inside of here, so it's operating on a S list from the beginning of the lecture, and it's going to pull the ABC out of this list and just put them in so that we get a single flattened list. And when we do this, you can see that even here where we went 2 lists in, that we pulled it all out and we flattened out the list. So I want to show you a couple of things that are different. Usually before we have used cons here, and in fact in our substitute, notice we used cons right there. Why are we using append? Well, in this case, we have a list of symbols, and here we have another list of symbols. Now we don't want it, this is not an element that we want to add to the front of our list. This is a list that we want to be included in the list. We want it combined with the other list. So this is another list. We just want to combine the other 2 together. So append right here is really what's flattening our list, taking out the list. Instead of adding an element onto the front of the list, it is combining the 2 lists into a single list. Now the other gotcha right here is this list right here. Why not just return the symbol like we did before? Well, since append needs to take a list and a list, if we're returning symbols sometimes and lists other times, that's going to mess up append, and append won't be able to add this symbol onto the front. So by putting the symbol inside of a list, that allows append to work. Now, as you read in the lecture notes, this append is actually a kind of expensive operation. So there's a simpler way to do that with auxiliary variables, and I'll let you look through that, and maybe we'll talk about that more in help sessions. But we're about out of time for this lecture, so thanks for watching.